Good afternoon. I'm happy to see that you made it all the way up to the top of the venue. At first I was a bit questioning, but why was I put in that room far off? But then it's the cookie room. There's the cookie station right down before the stairs. So, of course, this is a cookie room. Of course, we're going to be here and talk about the future of cookies. And a bit of history of cookies and how we ended up in this situation where we are, and what that, where that probably brings us. The history is clear, what has happened, and then I'll share my what I've seen in my crystal ball. It's not very clear all the time, but I'll try to make some predictions at least. So first, some cookie basic theory. When we make a GET request, we may have, when the server responds with HTML, it may also have a set cookie header that it returns. Looks like this: set cookie flavor chocolate chip. And then on any subsequent request that the web browser makes to that host, it will include the cookie in the header. Cookie flavor chocolate chip. Simple, fair enough, right? So if we look way back, how many surfed the web this long back? Oh, good. Actually, you remember, we had built-in cookie consent in the browsers, and it was enabled by default, because developers are normally quite privacy aware, and developers of the browsers said that, well, setting a cookie, that could potentially be tracking someone, so we should really ask for consent for the users. But compared to the modern cookie consent, this just says there is a cookie. Nothing about what the purpose of the cookie is it a necessary cookie, etc. Well, things moved on, and everyone was using cookies, no cookie consent. Nobody really cared, right? And everyone was happy. I was one of those that were happy. And my PowerPoint crashed, which makes me unhappy. My PowerPoint restarts. And I was happy. I had 2 megabit ADSL. Imagine 2 megabit to my home. That's downstream, half a megabit upstream. I was using one of these modems, Zixel modem. And one day on the internet, on a forum I fairly often visited, I saw someone asking, or a security researcher actually asking, do I know someone who has this brand and model of modem? So just a bit of background on this modem. The modem contained, among other things, a settings page for DNS settings, which was a form. You hit save. It led to some server-side thing on the modem that just saved and persisted the values and used them for the internal network. So this security researcher, he asked, do I know anyone who has this? And I said, yes, I do. I got a PM within 10 seconds. Hey, can you please try this link? And I was like, oops, is this a good idea? Well, of course I tried it. I'm curious. So I tried it, and I literally got a picture of kittens. And then I started thinking, is this really realistic? I mean, he went on this forum asking for people with a specific brand and model of a modem, and he sent those that answered. Obviously, he sent us each a PM. There was also a note in the PM, please don't tell anyone before this is published. So, of course, I went ahead and used the browser dev tools and checked what is in this page. Is it only kittens? Well, it was evil kittens. The evil kittens came with a hidden form in a hidden iframe that contained a primary and secondary DNS setting and posted them over to my modem. This is a cross-site request forgery attack. And what's important here is that I was usually logged into my modem. And since the request was done to the modem, my session authentication cookie was included in the request. Note that this also was back in the days before HTTPS was used everywhere, which meant that, I mean, he didn't have to do phishing anymore. When I entered the newspaper site, I ended up on his server with a fake newspaper site. Banks were doing HTTPS, but that was about the only ones. So if you could hijack the DNS settings of home networks, well, no phishing needed. But how come that the evil kittens, they are outside on the internet, on the security researcher site, how can they access? That's an internal IP number, right? Well, the trick is that cross-site request forgery means my computer that is on my home network is actually doing the request. And of course, my computer on the inside home network is allowed to access the inside interface of the modem. So cross-site request forgery made things a bit harder. And we were employing all kind of fixes, cross-site request forgery, guards in ASP.NET. We have the request verification token and things like that. But eventually, in 2016, the browser vendors stepped up and say that, hey, it's not fair that the developers have the full responsibility to protect their users from the evil hackers doing cross-site request forgery. We, as browser vendors, should step in and help. And this is where they added some features to the cookie header. They added a new concept. When a cookie is set, they added the SameSite attribute. We also have HTTP only and secure, which adds further security. So first, HTTP only means that JavaScript cannot access the cookie and read the cookie or read the cookie contents. Cross-site scripting, if we have a cross-site scripting problem on the site, it can no longer exfiltrate the contents of the cookie. Secure means that it should only be sent in requests which are HTTPS. So if there is a downgrade attack causing you to make an HTTP request, that would no longer expose the cookie contents of a, for example, conference Wi-Fi. And SameSite strict. So what's SameSite? Well, previously, the open model with before SameSite attribute was around, and if we didn't set a SameSite attribute, it meant that a cookie now would be sent in any cases. And that was the default. And then they introduced a new mode called SameSite equals strict, which meant that the cookie was no longer sent solely on depending on what site we were sending the request to. It also checked what is the originating site. So with SameSite strict, the evil kittens would still have been able to make a request to my modem, but the cookie would not have been included and the attack unsuccessful. SameSite strict is excellent from a security perspective, but it comes with another problem. That's when you go to your webmail and you click a link to your CRM system, whatever, e-commerce shop, something, where you are already logged in. So you get a link saying that, hey, please, can you review this document from a colleague? You click it, and you go to SharePoint Online, and it's supposed that you are logged in, right? So you are supposed to be able to access this protected content that you got via email. But if this is now a cross-site navigation, which means cookie is not sent. So you get to an access denied page on SharePoint. This is not a good user experience. So they added a lax mode, which is permissive for GET requests. And what is important here is that if you get your HTTP verbs right on your site, this offers good protection. Because remember, a GET request should never alter state. And the cross-site request forgery attack is a blind attack. It allows you to alter data or upload or post data to the target website, but the attacker will get no information back due to cross-origin policies. So everything was fine then, was it? Well, the problem here was that nobody was really using it. But first, just a bit about what are SameSite. So, are these two SameSite? Yes, they are, because they are under the same registered top domain, example.com. Are these SameSite? No. Scheme is a boundary. It wasn't at first, but it is a boundary. So it's a site boundary. And then I've given this talk in other countries, and then this was a thing. Now I'm in the UK, which means you know this probably. But are these SameSite? No. Because co.uk is effectively a root domain. What about Azure Websites.net? Well, it works the same. It's effectively a root domain. And there is something called the public suffix list, which contains a large list on that the browser incorporate, and it contains a large list of all sites on the internet where someone could register a subdomain of it. GitHub.io, we have Azure Static Apps.net, CloudApp.net, Azure Websites.net, things like that. So this is the Microsoft list, and it's the UK registry list that is sent in. So that's the site boundary. But it means that if you're normal company, you have example.com, then you do not have a site boundary between different subsites. So manual cross-site reverse forgery protection is still a good thing to do. So things were better. We had the threat of cross-site scripting in JavaScript. HTTP only mitigates that. We have the threat of an HTTP sniffer or downgrade attack and someone sniffing conference Wi-Fi. Secure mitigates that. And we had this cross-site reverse forgery problem, which SameSite mitigates to a large extent. But let's look back at how the cookie is set. So if I do set a cookie with flavor chocolate chip, SameSite strict, HTTP only, and secure, on the next request, when the browser sends in this, there's no information here. As when the web server receives it, there's no way for the web server to see that this was actually a cookie set with the security flags. I mean, this could be a cookie that was set by JavaScript. There's no way to tell. Or it could even worse be a cookie that was set by a subdomain, a domain-wide cookie. So consider a university. This university has a student project subdomain under the computer science department, where students can, well, they get a place where they can publish their serious research project. Students as a computer science, I mean, have you ever been at a computer science department at a university? Do we behave at that age? No, not really. So we might have hackers.student projects csabc.edu. They might set a cookie with a domain component saying that this cookie should apply to all hosts under abc.edu. And they are allowed to do it because they are on a subdomain, subhost or subdomain of abc.edu. And then they, of course, make some teachers, someone visit their site. And next time the teachers visit the admin site, they send along chocolate chip cookie header. And there's no way for this one for the admin site to know. But once more, the browser vendors in 2016 came and said that, well, we should step up. We should help the developers to protect their users from evil hackers, including computer science students. So what they added was a new prefix to a cookie. So if you name your cookie __ secure, and then whatever, that requires the cookie to be set with a secure flag. So that means that if a web server receives a cookie which is named __ secure, the web server knows for sure that this cookie was set with the secure flag and has never been exposed to HTTP. We have a more powerful one that we should use, the host, which says that it must be secure. It it must not be a domain cookie. Sorry, computer science students. And the path of the cookie must be the root. Because honestly, if you want to go check the active cookies on the domain, how often do you go and check all the subdirectories? For a cookie that is go to subdirectory? Never. So I think this is good. So the browser vendors had done the fair part of adding security features. But looking around the internet, most sites, same site, why? I mean, nobody was sending that attribute. So what the browser vendors did was that they went ahead and said, we are going to make Lax the default. Do you remember this? It was back in 2020, and things started breaking when Chrome did this change. Because suddenly everyone had to upgrade and be explicit and send the same site value of none. But there was another problem here. And that is that in the original spec, there was no none keyword. So in the original spec, it says that the same site attribute can have the value of lax or strict. And if the user agent would receive any other value that it doesn't recognize, it should treat it as strict. Fail-safe on the secure side. So when web servers started sending the value of none, Safari on iOS, on older versions of iPhone, treated that as strict. So this piece of code is rumored to have the origins at Azure AD. It's user agent sniffing, checking the user agent to decide, should we send same site none because it's a modern browser to get the cookies to work cross-site, or should we send nothing because it's a legacy browser to make sure the cookies work cross-site? Fortunately, if you have this piece of code anyway, you can now drop it because those old versions of the browsers are completely out of support. So now everyone was happy, right? Yeah, including this company, the Facebook Pixel. It's not really a pixel, but what it is a small sub-resource that site administrators add to the site, which means there is a request done to Facebook. So when we request the page, we have one GET request to our own server with our own cookie, but also a GET request to Facebook tracker with a cookie, the Facebook's cookie. And since this is done from a lot of sites around the web, Facebook can really build a strong profile of where you are navigating. And this is our normal cookie is a first-party cookie, and the Facebook cookie is a third-party cookie. And the browser vendors came along once more and said that, well, we are protecting our users, not only against evil hackers, we are protecting them against trackers. Now there is a slight problem here. Who put the Facebook pixel on the website to start with? The developers, right. So the browser vendors, they are no longer really on our side. In the mind of the browser vendors, we get off to that bad side because we brought in the tracker. So to protect against this, they decided to add features to protect against Facebook tracking. And honestly, I don't care that much if Facebook can't track me around the web anymore. But my background is that I work on single sign-on solutions. That is why I have an unhealthy relationship to cookies. Because another thing that requires cookies is single sign-on solutions. Especially the single-page application session management standard in OpenID Connect relies heavily on hidden iframes where cookies are sent in a origin or cross-site scenario. But to browser, I mean, they can't tell the difference. So single-page applications, they get broken, you can't sign in. if you use the old way libraries in a cross-site scenario. But what's even worse is that for server-side applications, you typically can sign in, and then you sign out and get this page. You are now logged out. The real problem here is that this is not entirely true. It's from the Domain Identity Server template. It says you're now logged out. This is actually a lie. When this page is loaded, you are not logged out of all the client applications, because this page contains hidden iframes that makes sign-out notification calls to all the clients that are a part of this distributed session. And that is the only way that a client application can clear its cookie, because a cookie can only be cleared in the context of a request to that site. So if this is a cross-site where we have our identity OpenID provider or SAML provider or WS-Fed provider in one site and the client application on another site, logout gets broken. And in my opinion, that's worse, because if the users are not able to sign in, they are going to call you. I'll let you know. But if we show a page, you are now logged out. I mean, I'm logged out. Thank you. Thanks that I could borrow your computer to do my important work. Now I'm logged out, so thank you very much. I'm handing it back. I mean, you can go in if I'm not logged out. So that is a real privacy problem. So the first browser that we will look at that started blocking third-party cookies is Safari. They were early on. So they had a situation where if we went to shopping.com, try to check for an existing single sign-on session with cloudlogin.com, it would fail because it was cross-site. But if we had another user that had first interacted with cloudlogin.com, been there first, logging in first, and then went to shopping.com, then it doesn't block the third-party cookie because you have interacted with them. And this is the way Safari tries to solve the problem of single sign-on. Because if it is single sign-on, you typically have interacted with the login server when you signed on. But if it's a tracker, who goes to an ad network tracker domain by themselves and interacts with that server, a web page? So this is fairly simple, and this is predictable. Safari wasn't happy. They wanted more. They added intelligent tracking prevention using AI. And I don't know what your opinion on AI is, but my opinion is that it may be a useful tool, but reliability and exactness is not exactly the strengths of contemporary AI. So if we want to see if a cookie will be blocked or not, this means it's kind of random. But what it does at least is that it checks the number of external sites that are accessing a specific sub-resource. So if we have a sub-resource that is accessed by 2 external sites, then it's probably one of our own assets. It's fine. Let's have the cookie through. But if we have another site that has a lot of, that is used as a sub-resource from a lot of places, that might be a tracker. What they check is sub-resources, iframes, and even top-level redirects. So so the first thing that came to mind from trackers was, of course, okay, if we can't use an AJAX call, we can't use a hidden iframe, why not just redirect to the tracker and back? A quick redirect, nobody will notice. So they are blocking that as well, bounce tracking. If they block it, they can ditch the cookie. That's fine. But this one, I think, is a bit more evil. If we have set the cookie as SameSite none, Safari can actually go in and change it to SameSite strict. And from a security perspective, when building single sign-on solutions, if I have set the cookie to SameSite none, I definitely want the cookie to be SameSite none. Because it is required to handle cross-site logout. If the cookie is SameSite strict, we can't access the cookie in a cross-site scenario, including a logout. So do you think Safari was done? No. CNAME cloaking. And this is a tracking I don't actually understand, but I think what it does is that Safari started blocking any access to tracker.com. So what they did was that shopping.com might set up a subdomain, CNAME, tracker.shopping.com to tracker.com, and then that meant that tracker.com could fingerprint the clients and get some tracking out of it. And Safari wanted to help on that and block that, which meant that when the ad networks started using CNAME cloaking, Safari blocked it. The ad network said, ditch the CNAME. Let's use an A record instead. Then it's not apparent that it's to shopping.com. Safari, in April last year, version 16.4, went ahead and said that you are not going to win. We have a remedy. So they started comparing the first 2 octets in the IP number of the hosting services. And I said, I did this talk at another conference in Oslo, and I said back then that imagine I figure out this would possibly create all sorts of weird issues for people. I mean, it's very unpredictable. If you use a CDN or just your cloud provider has not been able to get IP numbers from the same series or networks, then you will be caught by that. And after the talk, a man came up to me and said, presented himself that he worked for Schibsted, the major news media house in Norway, where they run online websites for the major newspapers in Norway. And he said that, back in April, we started getting problem reports from our users, specifically on Safari. There was nothing in the release notes, nothing else. We had to go read the WebKit source code to find out. And then Schibsted had to go ahead and they rebuilt their hosting infrastructure to get things on the same network due to Safari. Thank you, Safari. But then, what about bigger services? I mean, Netflix.com, they probably are hosting on all sorts of places. Google Docs, Microsoft Teams. Well, enter in the Safari source code, quirks.cpp, where it actually says, PlayStation.com, don't block, Teams.com, Teams login case, Sony Network Entertainment login case. So the Safari WebKit source code has exclusions where it disables some of its protection features for known larger sites to not cause problems with the users. And apparently the largest media house in Norway was not big enough to be considered. Okay, that's it what I have for Safari now, but I'm keeping a close eye on Safari. I'm sure they will come up with something more. Firefox, total cookie protection. If you're going shopping to shoes.com and diamonds.com, you have a Facebook tracker pixel on each. The idea here is that Facebook will be able to correlate because the tracking pixels are on the facebook.com domain and you will have cookies, a cookie. Firefox took another approach. They have different cookie jars. So now, depending on the context and the top-level site that you are navigating from, you actually have 2 different versions of the Facebook cookie. I think it's fairly clever because it means that it's not deleting cookies, which will break behavior. It's keeping the cookie run. But from a single sign-on perspective, I think this could be utterly confusing where we have different views depending on how we are navigating, whether we have a single sign-on session or not. And when we log out, we may log out, or we may have some sites client connected to one cookie jar, and we know how to log them out, but we lose track of the other ones. So it's unreliable. So let's look at the browsers. We've covered Safari. How does Safari make money or Apple make money? What is Apple's main revenue stream? Phones. The next one, I actually had to look it up. What is the main revenue stream for Firefox? It's actually Mozilla Foundation, and they get some sponsorship and stuff. Edge. How do they make money? Well, anyone using corporate software. It is only probably just corporate users using Microsoft Edge. And the browser we haven't covered really that here. Safari, Firefox are the major ones. Chrome is the large one. We haven't covered it. So how does Google make money? Ads. Of course. That means that ads and possibilities to track is a major part of Google's revenue stream. So they wanted to go along with this, but they were also careful, both for revenue stream reasons, if you are inclined to think that way, but also just for the sheer responsibility because of the size and market share of Google Chrome. So actually, you remember the SameSite cookie requirement that we started with, that rolled out and broke a lot of things? So they said that they were temporarily rolling this back. So why would Google roll it back once they announced it? There was this thing called COVID-19, where it was critical that healthcare sites around the world was working. And imagine, do you think the healthcare sites was the fastest one to adapt and correct SameSite headers? No. So this is from April 2020, where they actually had to step back. But Chrome said that they will do this. They will start blocking third-party cookies. In 2020, they said that we will do this by 2022. In 2021, they said that we will do this by 2023. In 2022, they said we will do this by 2024. And in 2023, they stuck to that and said we will do this by 2024. And actually, in January, they rolled it out for 1% of the users. I was among the lucky one. I got a notification on my phone, on my Chrome on my phone, saying that you are now one of the 1% of the users that do have protection. It started rolling out. They have said also that they will complete the rollout by December. So I got this notification. You are one of the first to experience tracking protection, which limits sites from using third-party cookies to track you as you browse. I have found sites that where login isn't working. I found sites that are broken. I just tried to log into some place in Sweden where to check an invoice that I had to pay. It's one of those where you don't get the invoice via email. You get a link and have to log in and check the current status of the invoice. And they have their customer portal on a different site or different domain in a different site than their identity provider. And it fails. I have to try to log in twice every time. So obviously there is some kind of fallback that if I try to go here, it might be that I have interacted with both the sites, and then the second time it works. It looks like this if you are one of the lucky ones on desktop. They obviously use this per device or browser because I don't have this behavior on my computer. I'm signed into the same Google account, which I find very unfortunate because if I got it on my computer, I can use the browser dev tools to play around and see how it works. But it's much more hard to analyze using my phone. But it works. Third-party cookies blocked. And I've not really cared that much before, but what an intense, extreme amount of third-party cookies that are used on some newspaper sites. This is Sweden's major newspaper site. So they are blocking it. But how come Google actually did this? You remember Google Ads? How are they making money now? So they rolled out another thing last summer, the Google Privacy Sandbox. And if you're using Chrome, you probably have seen the opt-in notice for this, where the browser now keeps track, or there is a way for sites to report via an API that, hey, I am a car dealer, and this browser just visited this car dealer site. So next time when you go to a newspaper site, the newspaper site can ask, okay, this browser, what kind of interests does it appear that this person has? And the browser can say that cars, shoes, and diamonds, because you've been to those kind of sites before. And this saves ad network tracking. But what about single sign-on? OpenID Connect front channel logout that we mentioned, and including OpenID Connect session management, it's the same principle, but two different parts of the spec. iframe-based background token renewal and iframe-based login widgets. They are not saved by an initiative to provide ad networks with interests of people. They are usually saved because of this interaction. So I think Chrome also detects that you've been interacting with two sites, and then it says that, well, probably it's fine. If you're interacting with two sites within a tight time frame, it's probably safe to assume that you want to share state and cookies between them. If you have one provider, but a common use for end-to-end identity server is a federation gateway, where the right-hand side might be Microsoft's Entra ID or a corporate provider or something where users actually sign on. That is where the users actually are interacting. While we have an in-between identity server that acts as a token issuer for a set of applications and APIs. Well, the idea of that intermediate federation gateway provider is that it should never be visible to the user. The user should never interact with it. It's just a bouncing point as it defines a security realm for applications and APIs. I think that this pattern will have a problem in a cross-site scenario because users have not interacted with the intermediate. Well, Google does not only care about ad revenue, they also care about that we are signed in with our Google accounts everywhere. It's even that Google, they have a fairly good OpenID Connect implementation for Google Login, except that they forgot to implement the end session endpoint for logout. So there is no API for logging out because they don't want you to log out of your Google account. So they added something called the Federated Credential Management API, which is new. And it's essentially, have you seen this pop up before where you go to a site and it says, hey, sign in to example app with Google. I'm always a bit worried when this shows up because at this point, it's actually, this is an iframe or some sub-resource loaded on as an overlay on an app. But at this point, I'm just surfing the web. I've never, ever consented that this site, booking.com or whatever it is, would have access to my Google account and know my identity. But they handle it, I think they handle it in a way to provide isolation. But they are now rolling that into the Federated Credential Management API. From what I've been seen and read earlier drafts of it is that it is very much centered around the concept that a website may ask the browser if the user is already signed in with the Google account. So essentially, the use case is you're signed into one or more Google accounts in your browser, and the browser comes in between to do privacy-aware mediation between the site. But the site can query, is the user already signed in with Google, then let them select which Google account do you want to use. I don't think, as far as I've seen, that there is a way to actually sign on. So for corporate setups, or where we have our own login or identity provider, federated credential management does not look to be sufficient. We will follow along what happens. I want to add one more thing, super cookies. So super cookies is actually not cookies. Super cookies is a collective name for other means that the ad networks took to track users. And it's fine for ad network tracking because they are 90% right, 95% right. That's enough for ad network tracking, but it's not enough for security where we need to be 100% secure. So I just wanted to mention them, but it's not part of the future of cookies. So to summary, my results, and if I look in my crystal ball, is that we should in the future think that cookies are first party and same site only. Any cross-site scenario, or where we use third-party cookies in a cross-site scenario, the browser vendors will filter out cookies in those scenarios for us. Single sign-on will probably work if we have an interaction at a regular interval. So single sign-on during the day, perfectly fine. Single sign-on long-lived sessions might be hard. I think Safari has a 7-day tolerance. So if you haven't interacted with the login provider for 7 days, it blocks the state. Single logout, front channel single logout is broken. And especially in cross-site scenarios, but might also be considered broken in, or not totally reliable. So we should go to back channel logout. And that's another talk, but there's a lot of work to this because normally we are representing a session just as a cookie in the client application, which means that if we get a back channel API call saying that, hey, session number 17 just signed out. I mean, the client application, what can it do? The web server, what can it do? Okay, session 17. No idea. It could possibly put up it on a block list and say that the next time a request comes in, it checks. Every time a request comes in, it checks if it is on the list of blocked session IDs, and then it could respond with a response that removes the cookie in that browser. Or we need to change our architecture. We need to start storing sessions server-side in a database or data store of some sort, and just have a cookie which is a reference number into that. Server-side sessions, that is a major architectural change. What about a high-volume site where you now suddenly need to access the database to query session state for every single request? But I think we're heading there. Well, that's my crystal ball. I'm afraid I had mostly bad news if you're using cookies and relying on them. So, any questions? Perfect. Perfect initiative, because this means we'll be the first one down to the party.